In this video, we're going to see how to apply the factor theorem in order to begin the factorisation of this third degree polynomial. So the factor theorem states that if we can find a value for z that will make this equation equal to 0, then z minus that number is a factor of this polynomial. It's a bit of a mouthful, so let's see how that works. We need to find a number for z, so we try a few numbers. Typically we start with things like 0, so if each of these terms were 0, no, it doesn't evaluate to nothing. Then we try things like 1, 2, 3, -1, -2, -3. Let's try z equals 1. If z equals 1, then this is 1, this is 5, this is 7. So 1 plus 5 is 6, plus 7 is 13, minus 13 comes to 0. So we'll say this: let z equal 1, therefore 1 cubed plus 5 times 1 squared plus 7 times 1 minus 13 equals 0. This implies z minus 1, subtract this, is a factor. That's the factor theorem. Now if we know that this is a factor of this polynomial, we can divide this linear factor, z minus 1, into this third degree polynomial to see what the quotient is, see what's left. And we do our long division in the usual way. Z minus 1. Now I know some of you are a bit rusty on this. Z cubed plus 5z squared plus 7z minus 13. Now it's important that this polynomial is written with all the possible terms: cubic, quadratic, linear and constant. If you happen to have something where there isn't, say, a quadratic term, put one here with a 0 coefficient so that the process works. Now we start by looking at the first one, z, and we imagine, what would I need to multiply by z to get z cubed? Well, the answer to that is z squared. We then take this and multiply by both of these terms here in the linear factor. Z times z is z cubed. Z times -1 is minus z squared. Just multiplying both. We subtract these two terms. Z cubed take z cubed is nothing. If this turns out to give a result, we've made a mistake. It should always be that these two leave nothing. 5z squared minus -z squared, that's the same as adding z squared, is 6z squared. Bring down the next term, plus 7z. Now what would you need to multiply by z to produce 6z squared? That would be 6z. So the next part is 6z. Multiply through. 6z multiplied by z, 6z squared. They must be the same for this to work. 6z times -1 is minus 6z. Subtract these parts. Once again, this is nothing. 7z, take -6, that's the same as add 6. 7z plus 6z is 13z. Bring down the next term, minus 13. What would I need to multiply by z to produce 13z? That would be multiplied by positive 13. So positive 13 goes here. 13 times z is 13z. 13 times -1 is minus 13. This take this is nothing. This take this. Now the fact that we've ended up with nothing as a remainder tells me that that term, z minus 1, divided nicely, completely into this cubic to leave a quadratic term and nothing left. So we finish by saying our original polynomial, z cubed plus 5z squared plus 7z minus 13 is the same as z minus 1, the factor that we discovered, multiplied by z squared plus 6z plus 13, this part. So our cubic now has a linear factor, which we discovered by trial and error, and a quadratic factor, which we would then go ahead and factorise by the completing the square from the previous video. So, as was shown in the previous video, which is just here still, the factors of this quadratic were z plus 3 plus 2i, z plus 3 minus 2i. I've skipped a bit of working, but you can see how to do that in the previous video entitled Completing the Square. So our cubic has 3 linear factors. One would produce a real solution, and these two would produce complex solutions.